In this video, we're going to be focusing on the management plane protection that we talked about in the previous video when it came to like control plane policing and control plane protection. This is where we secure the management plane, locking down the console and VTY lines. Now, we've already technically done that. I'm just going to show you a different variation of it with the control plane policing. So, the way that you do work with control plane policing is very similar to the way you would with control plane protection. So from our topology, this is one of those things I have to like walk you step by step through. So on R5, we would go to global config, and we haven't actually done this before, but we have to use what they call the MQC. We talked about this briefly in the QoS video, but I didn't actually show you how this worked. Now, in order for this to work correctly, we have to be able to do something about it. So, for instance, I could say I want to match on Telnet and SSH. But I'm going to create another line. I'm going to type in IP access list extended, and I'm going to say control CPP or COPP, control plane policing. And I'm going to hit the enter key. I'm going to say permit TCP any equal to 23 and 22. So it's going to say Telnet or SSH because both are allowed. So I'm going to exit out. What I need to do now that I have a matching statement, I don't have to use an access list. I could have used the network-based application recognition or NBAR to match on this as well, but that's increasing the CPU load. So I'm going to type in the class map config, class map of match this, and under here I'm going to say match, and I could say protocol. And this would allow me to match based off of any given value. So I could say 23, I could say SSH, I could do all kinds of stuff. I'm not going to do that, but I could. I'm going to say match access group, and this particular name of the access group here is called COP. I'm going to match access group COP, so match the ACL COP, access group name, and COPP. So that's the first thing I have to do. The next thing I have to do is create what they call as a policy map. So a policy map, and we're going to say do this. And then we're going to say under here, we're going to we have to call the class map. So class match this, which is right up here. Match this. Oop. And then from here, we're underneath the class map config. So now we've matched to something from the policy map. We're saying, okay, what do we want to match on? And now I have to go in here and do something with it. This is my setting command. So like in a route map, I have my match clause. Now I have to do something with that. I'm going to police the rate down to a minimum of 8,000 bits per second. That means I'm sending a lot of data to that. This is control plane policing. Okay, so anytime you do control plane policing, that's where this is going to come into play. Now it's saying, okay, if you get to this value, well, what do you want to do with it? You have three different options. You can conform, you can violate, or you can exceed. The idea here is if you conform, you are matching. If you're exceeding, you're going above the conform value, but you could say maybe remark it or do something, place it down. So you could do something along those lines. So we're going to say conform action is just going to go ahead and permit, or transmit, excuse me. There's a lot of options you can deal with here. When we get into CCIE, we'll take a look at DSCP and MPLS experimental bits and stuff like that. Set the precedence. So that's what we're going to do. This is going to be a single match, single color policer. So I'm going to exit out of here, and I'm going to exit out of here again. And I'm going to, one more time, type in do show run section class pipe policy. So the class map is going to call, let's see here. Well, there's a lot in here. So the class map match all, which says match anything, right? Or match all. They have to match in this particular case. This is a match and. This is a logical and. Match any would be a logical or. So it doesn't make much of a difference at this point. It says match this. So we're going to say match access group named COP, which is our control plane policing, which is named in the ACL control plane or COPP that matches on traffic from anywhere to anywhere as long as its destination port is either Telnet or SSH. And now do this is saying call the class map of match this. So we're matching the Telnet and SSH traffic, and then we're setting the police rate of the committed information rate, a consistent 8,000 bits per second. If it hits this value, go ahead and just permit it. If it exceeds this value, if it's up to and including 8,000 bits per second, it's going to conform and allow it to transmit. If I said exceed action would be to drop. If it went above 8,000, it would go ahead and drop it. So I don't have that particular portion configured. But if I typed in control plane and I said enter, now these other three that you see here, Ceph exception, host, and transit, this is where control plane protection is configured, is underneath these three. I'm under control plane policing under this guy. Under here, I would set the service policy. I could set the service policy and say service policy and call the service policy is going to be input. And I could specify the name of the policy is going to be do this. And it's set inbound. So R5 is going to be affected by this. So now it's being affected. So now it's been applied. If I do, now it says control plane policing feature enabled on control plane aggregate path. Okay, so that's a good sign. That tells us everything that we've talked about so far is enabled. So now if I type in show IP access list for COPP, nothing's happening. If I go to R1 and I hit the enter key and I SSH to this address, it's going to actually, I have to take the, oh, so it's, it's getting matched by that. Let me go back to, let's do the Smart 2 real quick. Telnet, Rob, and CCNP, login, and Cisco. When we go to R5, I have to wait a second for this to actually to work because we've got the additional AAA. If I typed in you all, that would turn this off. If I did a show IP access list, COPP, you see a bunch of matches coming in. So we see 32 matches hitting the this particular Telnet traffic. If I do a show policy map for, I believe it's control plane, yeah, control plane, and we hit the enter key, we're going to see that based off of this output, our it says the service policy input is do this. We're matching on match this, which is matching the ACL in COP, which is this guy right up. I don't have it pulled up at the moment. But there's 34 packets, 2,026 bytes, and the 5-minute average was nothing. Hardly anything, but I just enabled it. The CIR is 8,000 bits. Conform was 34 packets, or 2,006 bytes. So we have that. So if we come in here and do a little bit deeper, there's really not a whole lot going on. So now 2 should be connected. If I do, let me do a show tech support and hit the enter key, that's going to start bringing a bunch of data over. I'm going to hit the, now it's 79 packets. Now it should be done. So let's go back to this guy, 78 matches, 137. Now you see it actually working. Now you see where it says 137 packets conformed, 8,000 bytes, 58 packets were exceeded 3,000 bytes, which means it dropped, which means this output will eventually, I would say, would stutter. It would come in, it would be intermittent. So let's go ahead and try that again. It's going to go in, it's going to pull the running config, and that data is, every time you see it stop, is where it's being policed. All of that, every intermittent jump, is it being policed. So if I go back over here to 5, and it should, now it's done. If I hit the up arrow again, another almost more packets were policed and dropped than were permitted. Now I've got this at the minimum configuration just for demonstration purposes, but that's how you would do that. So if we do the access list, we had 1,300 matches. And the reason why is because all of that show tech support data is all just clear text data being sent back to the initial router. So back to R2, and R2 is receiving that data in and painting it. So all that traffic is going to be telnet. So it was an easy way for me to demonstrate control plane policing. But that's how you would control the management. So management plane protection could be a combination of both the locking down the VTY lines, or I should say the line, so console, aux, VTY. At the same point in time, it could also be control plane policing. So I could limit the amount of data. Control plane protection would be another step in that direction, but that's, I believe, a little outside of scope for right now. In CCIE, we'll cover that, but for right now, it's control plane policing is a pretty good jump for right now. That's what I wanted to show you guys in this video, just so you'd be able to see exactly how this would work. And it doesn't have to be just Telnet or SSH. This could be SNMP. I typically would increase the police rate, and the whole idea with this is to prevent the CPU from getting overrun. So if I had a bunch of situations in play where I had the device getting just pounded by hundreds and hundreds and hundreds of Telnet sessions, then this would not be a good idea. I would want to take control plane protection into consideration because it is going to block this stuff before it even hits the CPU. So there's going to be some processing on the ACL to block this traffic and to police it. Because there's got to be a match, the CPU's got to come into play. Now then again, we're on a software device. So at the end of the day, it's still going to be software that's handling all this. And because of the now, if you were to take like an ISRG2, like a 3900 or a 2900 or an ISRG1, like an 1800, 1841, or a 2800, those devices are software switched, meaning Ceph operates in software. The CPU handles everything, and Ceph is a software operation. When you get into the larger platforms, like your ASR 1000, your ASR 9K, your 7200 VXR, your 7600, your 6500s, those have dedicated line cards with CPUs on them where you're offloading a lot of these layered these functions to the CPU. The CPU is able to be handled on what they call the switch on chip or the port level ASIC. Port level ASIC has these ACLs downloaded to them, so it's the switch on chip, which is hardware Ceph, not software Ceph. So it's a little bit different of a situation, and you're not expected to know this for the exam, but just from experience and working in the field for as long as I've been doing it, there's things like that are going to be, it's going to be notable information for you to try to explain to your customers and to let them know, okay, well, there's a reason why you're seeing it that way. And I learned a lot of this stuff from watching Cisco Live videos and understanding how the routing architecture works. If you were to look up if you go to Cisco Live's website, so ciscolive.com, and you were to look up IP routing internals, it's a really good video. It's about an hour long, but it goes through all of the how the architecture of the platform works and the details behind it and stuff like that. Really, really good information. It's the stuff that I think is going to be, it's not going to be certification worthy information because it's platform specific. Where a lot of the certification stuff that we're covering is technology related, which means it's what the routers can do across the board, not what is limited to a specific platform or specific model of device or a particular line card or version of iOS. These are things that you're going to want to know, and it really comes down to it. The longer you're in the field, the longer you're doing engineering work, the more this stuff is going to become valuable, because you're going to be like, well, you know what? There's a reason why that's going to suck. Because, like, for instance, you take into consideration like IWAN. IWAN relies on NBAR heavily, and that can significantly decrease the throughput of your device because it's how much CPU has been allocated for application recognition. Where if I'm looking at like a lower end platform, I'm going to be cutting my throughput down to, 10, 20 megs of throughput, which is, if it doesn't matter to you, no big deal. But if throughput matters, you may want to consider a different platform in that particular device. Where if I go to where in the ISR 4K, those are all software Ceph. If I take it to the ASR 1000, then you're not software Ceph. You're in hardware Ceph because you have a dedicated line card. So these are things to keep in the back of your mind as you're trying to architect designs and stuff like that. What platform are you going to be using in the design or in this particular setup? And then when you've settled on a design and you're going to go with a particular architecture, what platform you're going to put in there, what services are you going to have to enable? And if iWAN is going to be one of them, keep that in the back of your mind. It was something that was just brought to my attention in the last few months because of the fact that I'm looking at a very large iWAN deployment, and I wanted to make sure that throughput was going to be sufficient for the platforms we were putting in play. So things to keep in the back of your mind, food for thought, just information I thought I would pass out because it's directly related to the CPU and how stuff like that can come into play and how that can potentially slow down your performance of your box. Just keep that in the back of your mind. Until next time, guys, thank you so much for stopping by, and we'll catch you in the next video.